Hi there, this is Ryan Malloy here at the Worldwide Center of Mathematics. In this video, we're going to go over some reasons for graphing tangents. Now for those who don't know, if you have a graph of a function, a tangent line is a line which sort of grazes the function. It only touches it at one point and can be thought of as being parallel to the function at that point. Okay, so what are some reasons for why we would want to know about the tangents of a graph? Let's say that we are told about some curve, which we are not given a strict definition for, but we know that it has these points somewhere on the curve. And we want to know what the general shape of the curve is. All right, well, looking at these points, we might think that it would go something like this. Might be a logarithmic curve or an upside-down exponential function. But suppose that we were given one other piece of information. And we were told that at this point here, the tangent line has a slope of 3. So it would look something like this. Well, that clearly doesn't match up with the curve that we sketched out before. So we might need to rethink about what this function might look like. So with that piece of information, and with nothing else, we might come to the conclusion that our graph looks something like this. Essentially the same as what we had before, but then here it dips down before shooting up. Okay. But let's suppose that we also know that at this point, the tangent line also has a slope of 3. Well, since the tangent line should be parallel to the curve at that point, again, this sort of goes against what we had originally graphed. So let's draw a different curve. It traces the points that we had before. Here it shoots up, shoots down again, then shoots up again. So the more tangent lines you have available for your graph, the more accurate of a representation of the curve you're going to get. All right, let's try another example. But this time we're not given any of the points. But what we are told is that at every multiple of 2 pi on and on to infinity, so we get 4 pi, 6 pi, suppose that we're told that in every multiple of 2 pi, somewhere on the graph, there's a tangent line with a slope of 0. So there might be one here. It's going to take wild guesses here because we don't actually know where they are. Okay. Well, if all of these have a slope of 0, there's a couple possibilities for what this curve might look like. One, assuming that these are all in the same line, is that we essentially just get a straight line. So see here, we have a tangent line, slope of 0. Same here. And so on and so forth. Alternatively, let's suppose that our tangent lines bounce up and down, so they're on opposite sides of our x-axis. So let's say we have one here, we have one here, and the same for the opposite side. Well, if we were trying to sketch a curve of this, might get something like that. And we can see that if this behavior continues, we'll probably get a trigonometric function. In this case, the cosine function. And finally, probably the least likely option is that we simply have a lot of hills and valleys in some very bizarre polynomial. You might get something like this. which is certainly possible. Functions like this don't come up very often, but they do exist. But in any case, just knowing what our tangent lines look like, again, gives us a rough idea of what the behavior of the overall function might be. My name is Ryan Malloy, and we've just discussed reasons for graphing tangents.